This is the first of 3 videos on a service tier architecture of 3 tiers, the first being presentation layer, which I present in some discussions on React. There's another one on MongoDB for the database layer. This one is the middle service tier layer. Some people call it web app layer or business layer. It's where all the logic in the middle happens. And this can be put into JavaScript, and our video series here is focusing on JavaScript Node.js. So Node and the JS stands for JavaScript. This then can be hosted in several different ways. The way we're going to host it is basically, ultimately, when we talk about the Newswatcher application in the 3rd video, you'll see code hosted in AWS, in Elastic Beanstalk, and also in AWS Lambda. Now, Elastic Beanstalk could easily be replaced with ECS or EKS, with those basically containerized, Dockerized type architectures. Let's get started then with what we're going to do in our backend service tier. So one of the main purposes for our service tier is going to be to expose an HTTP REST API. So this is an endpoint that you can use, say, Postman, for example, if you want to test it out, and you can give it a get HTTP verb, and you can get something. You could do a delete, you could do a post, you could do a put. And for our purposes, right, we're going to use JSON. Now, in the past, there were several different technologies, and there continue to evolve several different technologies like gRPC or maybe the SOAP protocol. For our purposes, we'll stick strictly just with JSON being transferred back and forth. The second purpose for the backend Node.js code is going to be to run something on a timer or something that needs to be run asynchronously. And a great implementation of that we're going to use is going to be in Lambda code. It can run up to 15 minutes. And for our purposes, we'll probably only have processes that run, less than a minute. This all plays in then into the larger view of what you want to do really with a backend Node service application or service tier. And that is, you want to split things out. Previously, you go back to the beginning of coding, and for many years and still today, people create single distribution of executables, and that executable basically runs once, and we can call it a monolith. And perhaps even worse is that the code is really intertwined. So the first step would be, if you're going to deploy a single application executable for your backend service, you would at least want to componentize or split up individual pieces of code, perhaps different routes that affect different parts of the application. If you've got enough people on your team and got enough time and enough resources, you should go service-oriented and actually split out into separate services, even to the extreme of perhaps something like what Netflix does or what Amazon does to create what are called microservices. So here's an image then that shows a presentation layer going through a single gateway service. So that gateway service acts as a layer of abstraction, as an intermediate gateway that then can reach all the rest of the services behind it. What it can do then is it could aggregate or create some kind of sequenced calls that actually need to piece together data across the backend services that exist. This way, if any of the backend services need to evolve or change or go away in any way, then you're kind of protected from that. But the point is, you would be writing these separate different backend services, such as for billing or customer profile or inventory or ordering or things like that. Let's go back to the beginning then and really talk about what Node is. So you can see on the left-hand side of this image is that in the past, you would write an application, and I used to do this. I used to write applications in C++. And you would write it once, and it would run on a certain operating system, because as you write an application, you're writing it, say, for Linux, you're using the low-level operating system SDK, and you're writing, to sockets, right? You've got you're listening on a socket, you're using UDP or TCP, you're interacting with the file system, you're starting up a thread, those types of things. Those are very specific to their usage on a given operating system. So you would write your application for Linux, and now you want to run it on Windows. And so you'd have to port that to Windows. Now, teams that were large enough, they would write some kind of abstraction layer on top of the operating system and then write to that, and then that would then go to the operating system. So the application writers would just have to write to that abstraction layer, and then they'd be safe. But still, you had to do that work yourself. So what happened is that a person named Ryan Dahl, he knew this concept, right? He was pretty smart, and he decided, I'm going to do this for people who are writing JavaScript applications. And what he had looked at, obviously, was, JavaScript runs in the browser, and it runs on any browser, and it runs on any operating system. And it does this because it has this engine called V8, which actually executes the JavaScript. So his brilliant idea was, what if I took V8 and instead of using it in a browser, I use it on the server side? No UI involved. I want to abstract away the interaction with, again, listening on sockets for UDP and TCP, doing the file system interaction. And so I can rewrite that layer, and then the Node JavaScript then gets translated into the actual operating system calls. And so that he was able then to provide us as developers today, as you see the top layer, we just write our JavaScript code, and we can also make use of these NPM packages, which I'll go into. Then the Node process runs, and it does everything underneath. So we only have to write once, and we can run on multiple operating systems. So that's basically the reasoning behind Node and why we want it and why we want to use it. Now, as an added bonus, if you use it, there's a huge community behind Node, and there's people who are writing these packages or modules that you can use inside your code to give you capabilities. If you want to access the file system or make HTTP requests, that's built in. Outside of the actual Node runtime itself, there's something called the Node Package Manager. So that's a site with over 1 million pieces of code that you can download that are contributed by individuals or even companies that put code up there that you can include in your Node application. For our purposes then, JavaScript, as we're saying here, for our React and our Node and our MongoDB interactions with the database, it's all based on JavaScript. It's all full stack. And that's the beauty of what we're trying to get across here. Now we can look at some actual JavaScript code, and we can run it with the Node framework. So let's look at the code first. So here's a simple file. If you look at the documentation, you'll find out there's this console object you can use, and off of that is a log function. You pass it a string, and it will output some text to the command line window. So here's our command window, and we run it, and sure enough, we get hello world. Now we'll get something a little bit more complicated. Again, I'm not teaching you JavaScript, so you have to understand the basics. You can have variables. These can be vars or lets or const, and they can be assigned the data types that JavaScript allows, such as a number or a string or an object or an array. So here's a function, and we're calling the function blah, and it takes 2 parameters, a number and a string. A simple test here, if statement. We'll return, if it's 0, we'll return can't do that. Otherwise, if it's anything other than 0 for the num parameter, we will take the string passed in, and then we'll uppercase that, and then we'll add power. So we'll take the number to exponent the third, and we'll then get the result back. That returns a result, and that gets stored into this variable, and then we call the console log. All right, so let's run that one. Okay, hi there, 343, 7 times 7 times 7. Let's move on to the next interesting example here. This is going to illustrate a point that if you saw the first two examples, right, they quit. Once they ran, they exited, right? So Node's not running anymore. What if we put it into an endless loop? So here's a while loop. While true, it's going to keep running forever. It prints hello world. Will JavaScript error out? It does not. So I'll hit Control C on my keyboard to stop that. So this is particularly bad. This is something you would never want to do in a Node application. If you did want some looping, then you could do something like this. And I just want to add one more line just to illustrate this. So this code is going to execute first. It's going to set up an interval. So an interval is code with a callback that gets fired every so many milliseconds, 1,000 milliseconds or 1 second. So every second we are going to print hello again. And of course, then we're going to hit this line, which is going to print hello again too. Now, interestingly enough, this line will print first, but the Node process will not quit. It'll keep running. And the reason is that Node knows when there's something scheduled to run. So it has this concept of an event loop. And it knows when something is going to be needed in the future. And it knows that one of those things that will keep it alive is a set interval. So let's go and run that. This is number 4. So we have hello again first, to first, and then we'll continue in this loop. So this will go on forever, and I'll have to hit Control C again to exit this. So there obviously are times in your application where you want Node to just run and then be done. The other times you'll want it to run continuously. A great example of that is an HTTP endpoint service. So we'll set up a listener, and it will listen for incoming get, put, post, delete requests, and it will give back responses. And obviously you don't want it to quit after the first request comes in. This is something that needs to keep going. So what if you mixed the two? This is interesting. So we have the interval with the while loop. And I'll just tell you in advance what's going to happen. This line will never print. In other words, it sets up the interval, but you are completely dominating that event loop. And once you get control in your code, the event loop will not interrupt your code. That's just how JavaScript runs. The only time it gets to run something else is if you give it a chance and you do something that's asynchronous. So let's run this. This is test number 5. Now we're going to have to, well, we've let it run for a while, and more than a second for sure. So if I scroll back through the text, you won't ever see it say hello again. Okay, let's keep going. Yeah, it's just hello world all the way up. Let's dive into callbacks and concurrent processing. We already saw a function in JavaScript called setInterval in Node that we are using, and it sets up a timer so many milliseconds later. If you remember, then it calls a function. So that's kind of like a callback, right? It's asynchronous. It calls that function when it needs to call it. Let's look at some other code here that kind of does the same thing. It has a callback function that gets called when something is ready for it. FS is something built into Node. We don't have to actually have it included in like a package.json that we'll get into here shortly. But we can just require it, and then we can use it. So it has to do with things that you want to do with the file system, reading and writing files. So we have a file locally called temp.txt, and we're going to read that file. Now, this is an asynchronous function. There's actually a synchronous and asynchronous version of this. Synchronous would block. Asynchronous doesn't. It lets Node basically go off on its own and then it frees up your main processing thread, because remember, you only have one thread to handle all your processing on that you want to handle. Node itself has back-end threads where it does things, and this is one of those cases. It takes that, it offloads it to one of its available threads, reads the file, and then when it has the file, the data ready, then it calls your function. So this is what we call a callback function. You get the data, you get an error, so we're going to print out what we find in the temp.txt file. Now, some of this other code that's there is just for illustration to also show how certain things are also non-blocking, in other words, asynchronous. And that's the case with console.log. It doesn't look like it because it doesn't really have a callback function, but what it's doing is it's using some underlying operating system capabilities to pipe data out to standard out and standard error, and that's non-blocking. It takes the data, and then as it batches data up, text up, it can then put it out on its own. So this is what we saw before. We have this function blah, we're going to call it. These are synchronous calls, but they're very fast, so that you don't have to worry about those. So if we go to run this now, we can see that we got both of them returning data. So we had our callback function returning data, which was from the file it opened, hello from temp.txt, and then the other function with a console log. Now we can dig into, if you can follow me on this diagram, right? I created this diagram in my book. Time goes from left to right. This is the exact code as it gets read in and executed in the JavaScript runtime in Node. So these first, I kind of bucket them in different calls that happen. So these first calls here, setting up the variables, and then doing the require of FS, the file system capability. Those just go to the Node library. So they either execute in so this upper box then is for what's running in your V8 thread. And then these are other parts of code that it calls into, and some of them actually have other threads that they invoke and can use so that they don't block you. So as it says right here, these are synchronous calls. So the require is a synchronous call. It won't complete, but these are really fast, right? To require a module is typically pretty fast. Then we define our function. It doesn't get called yet. Then we call the function. So the function gets called within inside of this console.log. So JavaScript hits this. It says, okay, call blah, which itself is synchronous, but the console.log part, when it gets a return from blah, is asynchronous. So it basically is going all the way down to the lowest levels of the operating system through the Node library, the C++ binding layer, and then to things we call libuv and whatnot, and finally the platform operating system. So libuv is basically what was ported across operating systems. Now we get to this interesting one. So the read file. So read file is also asynchronous, and it goes all the way back to the libuv worker pool queue. So if you called a lot of these read file functions at the same time, the first few would get run and distributed across the thread pool, but the rest would have to be queued up. So it has its own worker queue. In our case, I actually altered the name. I'm not reading package.json. I'm reading temp.txt. So anyway, what happens is the call to read that file goes down, and there's only so many threads that it has available, and just a few. Now, the nice thing is that threads can run on different cores if you got a multi-core processor on your machine. So it's not true when people say that you're only using one core. That is a false statement. Node actually does use multiple cores for I/O, and this would be the same if you were doing a TCP HTTP request. It would use the lower level operating system threading capability to actually fire off multiple HTTP requests at the same time concurrently, and then it manages that concurrency and parallel usage of as many cores as are available. So when they say it only, you only use one one core, one thread. Well, that is true only on your V8 processing. So eventually you get a return, and then your function gets called because the thread pool knows, oh, when I'm done, I need to call that function and give it the data. And so that is given back to you, and then the console log, as we saw again, makes this asynchronous call. I've got another great example here that's going to illustrate the concurrency and issues that you could run into blocking the V8 single thread that you've got. So Node has the capability then with HTTP to create a server and then create a socket and be listening for input. And as requests come to that socket that it's listening on, it can then make a response. So in this case, no matter what it is, we're just going to basically ignore if it's a put, post, or delete, and we're just going to return a response. And that code is right here. We're going to write a header, a 200 response code, and then in the body of that response, we're going to say hello world. Now, just to make things more interesting, we're also going to call this function called hash sync. And the number of rounds of hashing is given by a parameter here. This is synchronous. So the reason I'm putting this in here, as you'll see, is because it's going to block our V8 thread. Now, of course, on your back-end Node process, you've got multiple pieces of code that could be happening at once. You could have different routes, right, that are handling different parts of the API. You could also have things that are happening on timers. So let's throw this in here, right? So we got a timer that's going to go off, and it's going to also log the count. So we've got the count coming out here. We got the count coming out here. So let's go ahead and run this. Okay, so count is 0, and we see that that's going on. Now let's try a curl request. So this is just an executable you can install on your machine, and you can make HTTP requests. So we're calling to our localhost 3000. Now watch what happens on the left here, right? It's blocking. That's because that decrypt is going on. I'll do it again, and it blocks. So that's not good. Again, as I said before, you don't want to be blocking your thread, and that's what's going on here. So we can put in some code to make it so it's not blocking anymore. So let's go ahead and use the asynchronous version of this. So we're going to comment this out, and we're going to copy this in here because perhaps we don't want to return until the bcrypt is finished. Okay, so now we've got that. Let's see what happens this time. Start it up again. Okay, now watch when I run the curl. It didn't stop. And now it returned finally. So you can see that it's incrementing that count, and about 5 seconds later it returns. So the reason it can do that is because we have set up the asynchronous call usage. And bcrypt is able to do that because it can offload that processing and use another thread. So people can actually implement, for example, a NPM package in C++. Then they've got complete control over the operating system and can do whatever they want to then use multiple cores and multiple threads and do things in parallel and all of that. So that's the concept of concurrency. Now, it's kind of different from parallel processing. So let's go back to the case where we're opening files. So we're not going to, in parallel, open up 1,000 files. We're going to do it concurrently or make HTTP requests concurrently. So if we were able to place requests out across the internet, those would all go out, but they would be running concurrently. In other words, some data comes back from one, and then it gets back to your thread. And then data comes back from another, and then it gets back to your thread. So in other words, if we go back to the other example, you're not going to get parallel calls back to this function. You're only going to get one at a time. your thread, again, I'll emphasize this, in V8 will only be running one piece of code at a time. So it's either going to be running, like it's going to be running this code right here, this console.log, or it's going to be running this code. It won't be running them both at the same time. This is the concept of concurrency. Things can happen and you can concurrently kind of shift back and forth between the code that's running, not by interrupting it, but by that code finishing and then giving Node a chance in the V8 processing to then go, okay, what's the next piece of code that I need to run? And that's illustrated again in the diagram here that shows you've got your thread, and that thread has events that are going on it, and those get sent to you for your availability to then run your code. Creating and consuming modules is a very important topic. It's something we've been doing already, but now we'll dive into the specifics, and we'll look at those that are inherent to Node itself, those that you can pull in from NPM, and how to create a module on your own, whether or not that's just internally exposed or even exposed on NPM if you would like. If we go back to this test file that we had, here's the HTTP module. So you can actually go to the documentation on Node. You could find that. I've actually opened up the file system one, and this talks about the FS module that we saw in code and how we did a read file. So HTTP then is one of those that you can pull in and use. Bcrypt.js. So this is a little bit different. So this is surfaced through NPM. So if we went to the NPM Bcrypt.js, we'll look at that up. Okay, there it is. You can find it here. You can see it's got a lot of downloads every week. It gives you information about how to install it and then how to use it. So then we want to install that before so if I were to run this code now, I've scratched everything and we've started from zero just with this file. It wouldn't actually run. So what we need to do is we need to get a package.json file. So the package.json file, you can just run this npm init-y command. That'll give you a package.json file. Right now it's empty. There's nothing in it other than the description and something like what's the main module it needs to run, some scripts. So what we want to do is we want to run a command which is npm install -- save, means save it to my production dependencies, and we can install bcrypt.js. Two things are happening here. So it's adding a line to our package.json. Okay, it did that. All right, so if we look at here, the dependencies, we see bcrypt was added. Now, I didn't specify a version, and so if you don't specify a version, it will give you the latest, and so it happens to be 2.4.3. 2 is the major version. So if you ever see that change, it's likely that you'll have to change your code. And then the other versions are the minor versions, and those are less likely to cause a change. Now, if we also look at something else that happened, it created a directory for us called Node modules. And there's bcrypt. So these are all the files. You actually have all the code for bcrypt. It's all right here. And you could look at it at your leisure, see how it works. So that's how you install a module from NPM. And as you have, a more significant project, then you'll actually be having dozens of dependencies here, and that Node modules will get very large, mostly because a given package that you bring in will likely have dependencies that it will bring in, so it will balloon quite rapidly. Now if we go back to our code, we could see that we can require it and we could use it. So how do I create a module of my own? So let's look at a very simple module. called mymodule.js. So inside of the Node syntax for JavaScript, you can basically open a file and you can say module.exports, and then you can give it some text here. I call it welcome. And then I have a function. It's not named, but it does take a parameter called name, and it prints a statement. It says console.log hi name. So how do I call that function? So this is a function that's in this file and it's being exported. Well, it's very simple. Again, the same require statement. Now, you saw the other require statements that were being used. This one, however, has this little prefix here. It's basically saying, look for this file locally in my same directory. And then it assigns it to a variable. Now we've got that, and then we can call the welcome function that was exposed. So if we run this, it says, hi, Bob, because that's what we were passing in. Let's look at one that's a little bit more complicated now. So here's my module 2, and we're doing a require. So your modules can require other modules. I happen to require HTTP here, and I don't use it. It's just an illustration, just to show you that you could include other modules. What we've done here is we've kind of created this function class. So it's a function called welcome, and we're going to use the JavaScript prototype capability to add other functions on top of that welcome. And so when we instantiate this, we can pass in a name, and that gets put into the local this of name. And now we've got two functions off of that we added because of the prototype capability. So we have a function called showName and a function called updateName. So when we call showName, we want to do console log hi this.name. And then when we want to update it, then we update this.name. So let's make a little bit of an alteration here. Get rid of this code. Now we're going to require that module. We're going to do a new of that. So we've got welcome that comes out of it. And we want to then, because we're actually exporting it directly, right? We're exporting it a little bit different than the way we exported it over here, as you can see. So here the whole thing is being exported. So if we include it, then we get direct access to welcome. So over here we could export multiple things. We could have multiple functions. Welcome 1, welcome 2, welcome 3. Here we're just exporting, the one function here we've got here, and we're going to basically create new that and then be able to use it. So here we have the new of that as a class, and then we've got access to the prototype functions, showName, updateName, and then we're going to showName. So we expect to see, John to begin with, and then it's going to change to blah. There we go. Hi, John, and then hi, blah. So that's the basic concepts of using modules and creating your own modules, because obviously in Node, you don't want everything in one single module or one single file. So you create all these other JavaScript files, and then you include them in your application. And as we get later on and I get onto the Newswatcher application, you'll see all the different modules that I created and how they're consumed.